Hydraulic Actuation Systems Part 1. Principle used in and advantages of hydraulic actuation systems. Introduction. Hydraulic actuators, as used in industrial process control, employ hydraulic pressure to drive an output member. These are used where high speed and large forces are required. The fluid used in hydraulic actuator is highly incompressible, so that pressure applied can be transmitted instantaneously to the member attached to it. Request. It is hoped that this lecture is going to be useful to you. Please press like. Please subscribe. Principle used in hydraulic actuator system, that is Pascal's law, amplification of force and conservation of energy. Pascal's law. Pressure applied to a confined fluid at any point is transmitted undiminished and equally throughout the fluid in all directions and acts upon every part of the confining vessel at right angles to its interior surfaces. Amplification of force. Since pressure P applied on an area A gives rise to a force F, given as F equal to P multiplied by A. Thus, if force is applied over a small area to cause a pressure P in a confined fluid, the force generated on a larger area can be made many times larger than the applied force that created the pressure. Conservation of energy. Since energy Conservation of energy. Since energy or power is always conserved, amplification in force must result in reduction of the fluid velocity. Indeed, if the resultant force is applied over a larger area, then a unit displacement of the area would cause a larger volumetric displacement than a unit displacement of the small area through which the generating force is applied. Thus, what is gained in force must be sacrificed in distance or speed, and power would be conserved. Major hydraulic and mechanical variables. In this diagram, we can see that the pump is giving rise to flow of the fluid Q, and major hydraulic and mechanical variables. In this diagram, we can see that the pump is giving rise to flow of the fluid Q and generating a pressure P. This pressure P is being applied on the area of cross section capital A. P multiplied by capital A is the force and this force is being experienced by this member or the piston. Advantages of hydraulic actuation systems. The advantages are variable speed and direction, power to weight ratio, and stall condition and overload protection. Advantages of hydraulic actuation systems. Hydraulics refer to the means and mechanism of transmitting power through liquids. The original power source for the hydraulic system is a prime mover such as an electric motor or an engine which drives the pump. However, the mechanical equipment cannot be coupled directly to the prime mover because the required control over the motion necessary for industrial operations cannot be achieved. In terms of these, hydraulic actuation systems offer unique advantages as given in the following slides. Variable speed and direction. Most large electric motors run at adjustable but constant speeds. It is also the case for engines. The actuator, linear or rotary, of a hydraulic system, however, can be driven at speeds that vary by large amounts and fast by varying the pump delivery or using a flow control valve. In addition, a hydraulic actuator can be reversed instantaneously while in full motion without damage. This is not possible for most other prime movers. Power to weight ratio. Hydraulic components, because of their high speed and pressure capabilities, can provide high power output with very small weight and size, say in comparison to electric system components. Note that in electric components, the size of equipment is mostly limited by the magnetic saturation limit of the iron. It is one of the reasons that hydraulic equipment finds wide usage in aircrafts where dead weight must be reduced to a minimum. Stall condition and overload protection. A hydraulic actuator can be stalled without damage when overloaded and will start up immediately when the load is reduced. The pressure relief valve in a hydraulic system protects it from overload damage. During a stall or when the load pressure exceeds the valve setting, pump delivery is directed to tank with definite limits to torque or force output. The only loss encountered is in terms of pump energy. On the contrary, installing an electric motor is likely to cause damage. Likewise, engines cannot be stalled without the necessity for restarting. Next lecture. The name of next lecture is Hydraulic Actuation Systems Part 2. In the next lecture, components of hydraulic actuation systems shall be discussed. Request. It is hoped that this lecture is useful to you. Please press like. Please subscribe.